Alright guys, welcome back to Geometry B. We are in week 5 of this continuous learning. Hopefully everybody is staying safe. Last week we looked at arcs and central angles. This week we're going to be looking at arc length and sector areas. Okay. And so let's go ahead and start with our objective for this week. So our objective is I can calculate arc lengths and sector areas given radius, diameter, so radius or diameter, and central angle. Okay. So in order for us to be able to follow along, let's go ahead and look at some vocabulary. Okay. So we have arc length, and we're going to look at this a little bit more visually. Sector area and central angle. Okay, so these are our three words that we're focusing on. So our arc length, think about if you have a circle, okay, and obviously we talked about how we have a center. So the arc length is, imagine if I'm taking kind of maybe a motion and I'm sweeping around. And so my arc length is imagine that we take that distance around. Okay, so our arc length is the distance around the entire or part of the circle. Okay. Sector area sounds exactly what it sounds like. So here we have a sector, like a section. Okay. So again, imagine that we have a circle. Okay. And so here in this circle, again, we have a center. And let's for now take this same circle and talk about central angle. So we talked about central angle last week. Okay, we said that if we are looking from the center to the edge and we connect two of them, right, then our central angle is this measure. And so here, we weren't given measurements in some of them last week, but remember that it can be measured in degrees. And so a full circle is 360. Okay. But we also have something called radians. And so radians measures the entire circle, and it says that the entire circle is made up of 2 pi. Okay. All right. So in order to find the sector area, I need to have both a central I need to have a central angle. So here, for example, I'm going to draw my central angle from there to there. And so my central angle um, tells me how much of the area is being swept. And so when I find the sector area, I'm technically looking at that. And so the best way to describe it is kind of like a slice of the pie. And I'm trying to draw it as best as I can, but here notice that that section has been highlighted in green. And so here we're going to go through and only focus on that section. And so here I'm going to go through. And so my section is this piece here. Okay. So I will be using area equals pi times radius squared. Okay. And that's the for the entire circle. And so in order to find part of the circle, I'm going to be multiplying by the angle. Okay. So here, let's make sure we write down our um, so we have 2 formulas. So the area of the entire circle would be pi times radius squared. But since we're looking at the sector area, just the green part, we're going to take our circle and we're going to multiply by our angle, right? That's out of 360. So our angle, which we're going to call theta. So let's call this our angle out of 360. Okay. The other one is looking at it if we had radians. So here we would say 1/2 times pi r squared times our angle. Okay. So let's go ahead and look at an example. Okay. Um, so again, let's assume, let's go ahead and bring in, say, in this blue. Okay, so let's look at an example. So let's assume that we have a circle. Okay. I know that the center is here. Um, I want to find the area of this section here. Okay. So here, okay. So here's our circle, right? Let's say that we wanted to identify just the area, okay? So the inside of this section. In order to do that, we need to know what the radius is. So let's say that here it says 5 centimeters, okay? So here we would take um, so we have this setup. And so these two formulas are helpful, but we can sum these up, okay? So we're gonna take this and say, okay, let's shrink them, okay? Because this here tells us um, a couple of things. But we can definitely put this and sum it up into one equation. So I'm going to write this one in blue. So here I could have area of a sector. And that's going to be over area of circle, okay, is going to be equal to the central angle divided by 360. And so this formula kind of puts together the first equation, but in a sense that we can be looking for any one, right? So if I give you the central angle, and if I give you the central angle and the radius, then you can definitely find the area of the whole circle and then use that to find the area of the sector. Okay. So here, for example, let's say that our angle is and take this one and erase a little bit. So here we can say that our angle is, let's say this was 45 degrees. Okay. Trying to eliminate our shading. So here, this is our angle. Let's say that this is 45 degrees. Okay. And we want to identify the area of the inside of it. Okay. So we're going to take our equation. Okay. So we know that the area of the circle is pi times radius squared. So we're going to say sector area equals pi times radius squared times your angle out of 360. Okay. So that means that actually it does equal that, but I want to show you where it comes from. So here, let's take this, copy it, and we're going to use it here. Okay. So we need to identify all these pieces. Okay. Obviously, we know that the area of a circle is pi times radius squared. We know that the full circle is 360 degrees. Our central angle is 45 degrees. Okay. And so the area of the sector is what we're looking for. Okay. So the area of the whole circle is pi times 5 squared, which is 5 squared is 25. And so then we'll have x, because we don't know what the area of the sector is equal to 25 pi. Over 25 pi equals 45 degrees over 360, because our central angle is this piece here. The full circle is 360. The area of the sector, that's the shaded part of that piece. Well, we don't know that, so that's why it's x. And then the full circle's area is found by area equals pi r squared, and this is our radius. So then 5 squared times pi is 25 pi. Now, in order to get x by itself, we know that here we are dividing by 25 pi. So then the opposite is to multiply by 25 pi. And so then here I'll get 25 pi. So by doing that, these two cancel each other out, and I'm left with x is equal to 45 over 360 times 25 pi. And so now you can take that and bring your calculator in. Go ahead and clear your calculator. Okay. And you'll have 45 divided by 360. I did put it in a parentheses because I wanted to stay together. And then times 25 and then we'll put second pi, and then close the parentheses. So both of those can go in their own set of parentheses. And so then I'll get x equals, and the area is 9.82. I'm going to put 9.817. And then let's go ahead and round our answer to the nearest hundredth, which means x equals 9.82, and it's going to be centimeters squared. So that means that this section of the circle is 9.82 centimeters squared. Okay. Um, okay. So now if I wanted to find the arc, right, then I would do a similar process, but instead of the area formula, I am going to use the circumference. And so remember that the circumference is 2 times pi. Okay. And so this here was to do the sector area. Okay. And so let's go ahead and change our green to our purpley color. Okay. So now instead we want to find just the measure of this length here. Okay. So that right there is called the arc length. So here we're going to put this here is the arc length. So we're asking basically, what does my circle measure? Okay. And so we have two formulas, and so we're actually going to put them over here. So we have arc length equals, if it's in radians, it's going to be the radius times central angle. Okay. Divided by 360 or 2 pi. Okay. So here we'll have arc length. So we're going to call arc length equals S. Okay. So we're going to have S equals, well, let's just continue calling it arc length. So we'll have arc length equals the radius, which is 5 centimeters, times the central angle, which is 45 degrees, divided by 360. And it will be remember that the full circle is 2 times pi. So we'll have 2 pi times radius. So let's go ahead and move this here. And we'll have 2 times pi times 5, and then times 45 over 60. Okay, so here 2 times 5 is 10. So 10 pi times 45 over 60. And so over here, we'll clear and we'll do 10 pi. And then if it'll be easier if we keep them both in parentheses. So 10 pi and then times 45 over 360. Remember 360 because it is a full circle. And so then here we have 3.926, which means that arc length is equal to 3.93. Okay. And so then that there is the arc length. Okay. So let's go ahead and I'm just going to change all my calculations to blue just so that okay. So there we've gone through and identified the area of the sector as well as the arc length of that sector. Okay. So we are going to look at one more example. And so the other example uses radians. So these here we had a 45-degree angle. And so the other example takes and uses radians. So I'm going to move on. Well, actually, I think I can do it here in this section. Okay. So here's my second example. I do have a circle once again. Okay. I do have a center. This time though, we have an angle that's a little bit different. So I'm going to take my green and we have from the edge to the center and from the edge to the center. But now instead of using the other side is we are going to go from here to here. We have that this is 11 feet for our radius. And this here angle is 3 pi over 2. So that right there, 3 pi over 2, that is what we call radians. Okay. Radians means that it uses pi as part of its numbers, as part of its measurement. Okay. So the idea is still the same. If we wanted to find the area of the sector, keep in mind that we would be talking about this part of the circle, right? Identifying this area here, which is what is saying when we follow that angle, okay? So again, we're using the same formula, but now instead of using 360, we're going to use 2 pi as our full circle, okay? So here, I'm going to say, so area of sector, and then divided by area of circle equals to central angle divided by, and this time instead of 360, we're going to use 2 pi as our measurement of the full circle. And the reason why we're doing that is because we have radians in our measurement. Okay, so here, remember that the area of the circle, so we're going to say area equals pi times radius squared. So since we have the radius is 11, we can say area equals pi times 11 squared. 11 times 11 is 121. So we can say that the area is, of the full circle is 121 pi. The central angle, in this case, the central angle is 3 pi over 2. And the sector area is what we're looking for. So we're going to call that x. So we don't know it, and that's why we're going to call it x. Okay? So this piece here, this piece here, the area of the full circle, goes here. The central angle goes here. And then what we're looking for is the sector area, and that's why the question mark is going to be replaced with an x. Okay, so here we're going to say x divided by the area of the circle, which we said was 121 pi, is equal to the angle, which is 3 pi over 2, divided by 2 pi. So in this case, I'm going to change, first I'm going to do a couple, before I try to get x by itself, I need to simplify this, okay? Here I have a fraction within a fraction, which isn't pretty, and it's not something that we're used to seeing, so we want to get rid of that fraction over a fraction. So I'm going to have x is equal to 121 pi, and that's going to be equal to 3 pi over 2 divided by 2 pi. Hopefully this isn't too left field for you, in the sense that you remember how to multiply and divide fractions. Don't worry if you don't. You can definitely put this into the calculator and just get your answer. But you're going to see that something interesting happens. So I'm going to take 3 pi divided by 2, close that parentheses, and then divide by 2 pi, and you get 0.75. Now, what's happening here is I'm going to have x equals 121 pi, so this side is not changing, but what happens is you keep your first fraction, and then you change to multiplication, and you flip your second one to be 1 over 2 pi. And so what happens is that your pi's cancel each other out, and then you're going to be left with x over 121 pi is equal to 3 times 1. So now what I'm doing is taking this 3 and multiplying it by this 1. And so by doing that, I get 3. And then I'm going to take 2 and multiply it by 2. So by doing that, I end up with 4. And 3 divided by 4 is 0.75. Okay? So obviously you can do it on the calculator, but understanding what your calculator is doing is somewhat important because the calculator can only do as much as what you put in. And so if you put something in correctly and you're not double checking your work, then you're just following along with what the calculator is saying without understanding it. Okay? All right, so then here, just like before, I'm going to multiply by 121 pi on both sides. And so by doing that, those two cancel each other out, and I'm left with x equals 0.75, which is 3/4. So 3 divided by 4 times 121 pi. And so then I get that x is equal to 285.099. We're going to round to the nearest hundredth. So that 9 turns it into a 10, which means that x is equal to 285.10. Excuse me. So this here is the area of the sector. And then to find the arc length, we were going to say arc length equals, so remember arc length equals 2 times pi times radius times, so 2 times pi times the radius, so that's a full circle, times the angle, which is 3 pi over 2. Okay. So here it's going to be times the central angle. So let's go ahead and put it in general first. And so then that would mean that the arc length is equal to 2 times pi times 11 times 3 pi over 2. Divided by 2 pi. So divided by, in this case, divided by 2 pi if it's in radians. So over 2 pi. So this here turns out to be the same, okay, in terms of this fraction here, okay. So I'm going to have arc length is equal to 22 pi, because 2 times 11, times 3 pi over 2 divided by 2 pi. Do this on the calculator. You do this part on the calculator, you will end up with the same idea that you have 22 pi times 0.75. And so then you'll take 22 pi and multiply it by 0.75. And so then you'll have that your arc length is equal to 51.836, and we're rounding to the nearest hundredth, which means that the arc length is equal to 51.84, and it's feet. So the arc length is feet, and because it's, think about like bringing a string and just wrapping it around just the edge of the part of the circle that's shaded. So that one here would be the arc length. And then the only thing that we need to do is make sure that this one is feet squared, because remember that it is an area. Okay. All right, guys. So that concludes our notes for today. Make sure that you're coming to office hours Wednesdays and Thursdays, 9 to 11 or 2 to 4. And as always, thank you guys for watching. If you have questions, make sure you're coming